Global illumination shadows. So previously we saw a couple of global illumination algorithms. We had this Cornell box scene, we have some objects in the scene, and we see that this red light from the left is shining and reflecting on this face of the cube. But there is one important thing missing from this picture, and that is the shadow of that object. So this object actually occludes a lot of the light coming from the light source. So the fragments down here, they actually don't get the light directly from the light source, because the cube is kind of blocking that light. So one way to create these shadows is to use these shadow rays. We already briefly saw that approach in the global illumination video, but basically when you shoot the ray from your camera, you find your hit point, then instead of just calculating your regular direct illumination lighting model here, you shoot another ray onto the light source. If it hits something, well, then there's an occluder on the way. This shadow ray tells you this, and you don't render the direct illumination because it's blocked by this occluder. So let's see what actually happens with the light to create these shadows. When we have an area light on the left here, it's shining light onto the scene. We have an occluder, and let's look at what happens in this section. Well, if you have a camera here, this camera just sees the entire light source. There is no shadow, all of the light from the light source is reaching this point. But if we move the camera back here, then this occluder, it's occluding all of the field of view of that camera. So we do not see any light, we just see the back side of this occluder, let's say it's black, so we are in the shadow. This part where you're completely in the shadow, this is called the umbra. But you might also be on the side here. So here, some part of your field of view is occluded by this occluder, but some part is not. So on the left, we do see some of the light source, then we see this occluder here. So we're kind of in this half shadow. And this part is called the penumbra. And it is actually a gradient. So more closer you are to the umbra, more of this occluder is occluding the light. And more further away you are from the umbra, less of this occluder is occluding the light. So those shadows don't just start very sharply, rather they have this gradient that leads from a completely illuminated area to the full shadow. But you might also be back here. So here, the middle part of your field of view is occluded, but you see the light source all around it. So this is kind of the after shadow called the antumbra, and this is also a gradient. So further away you go, the smaller this occluder will be in your field of view. And these are the three parts of a shadow. Umbra, the full shadow, the penumbra, half shadow, and the antumbra, after shadow. Now here we had a case with this area light. Let's see what happens with our analytical light sources that we have used before. With a directional light, you have this infinite plane that is shooting light at a certain angle. So in this case, you don't actually get this penumbra part because light is only coming in this single direction and you are either not in the shadow or in the shadow. Similarly, with a point light source, another analytical light source, you have light being emitted from a single point. So in your scene, you are either in the light or you're in the shadow. Now from this video, you should understand global illumination shadows, namely shadow rays. So when you have a global illumination algorithm that uses ray tracing, then you can shoot those shadow rays to calculate a shadow. And you should know more about shadows, the three parts of a shadow, umbra, penumbra and antumbra, and the behavior of those parts with area light sources versus those analytical light sources.